Okay, 1.3, we are going to learn what equivalent linear relations are. So if you have a line and you have another line, these are not equivalent because they're two lines. But if they are the same line, they're equivalent. You might be thinking that's really easy. Things are hidden in math when things are the same. So for instance, if I graph one line, I graph another line, and they are different lines, for sure they are not equivalent. But if I graph two lines on the same graph and they are in fact the same line for whatever reason, we call them equivalent linear relations. So here I'm going to graph y equals negative a half x plus 3 and x plus 2y equals 6 on the same graph. I'm going to use whatever strategy you want. This is in y equals mx plus b, so I'm going to use slope-intercept form. I'm going to start at 3. I'm going to go down 1 over 2. And I only need 2 points to draw a line. I don't have a grid, so I'm not sure how accurate I'm going to be. But there is y equals negative a half x plus 3. This next one, however, I'll graph in orange. It's not in y equals mx plus b. So I can change it into y equals mx plus b, or I can just graph it in intercept form. I already know the x-intercept is 6. That's an easy one. So at 6, I'm going to plot a point. And then the y-intercept is 3, if you can see that. I'm just dividing the 6 by 2, and I get 3. Okay, and while it doesn't look to be the same in this case, because I don't have a grid, these lines are exactly the same. Okay, I'm just off because I only drew 2 points. So I can continue my slope, down 1 over 2, down 1 over 2, and it's going to land on that 6 as well for that other line. Okay, doesn't look like they're the same, but they are when we graph them. And now obviously we're not going to try to determine things are the same by graphing them, it takes too long, so there is an algebraic way. If you just make them look the same, the differences will stand out to you. So for instance, I can either move the x's and y's over to the left and put the number on this side and make them look like this, or I can solve both for y and make them look like this. So I'm going to solve this one for y. So x plus 2y is 6. I'm keeping the y on this side. Notice how now I'm putting negative x plus 6. I would never do that. I would put 6 minus x. It's less writing. But negative x plus 6, because I want it to look exactly like this, with the x first and the number second. And I'm going to divide both by 2. To some of us, this might still not look the same, but this is the same as negative 1 over 2x, and this is a 3. So algebraically, these are exactly the same. Okay, it's going to be important to understand equivalent linear relations because in elimination 1.4, you have to come up with a bunch of equations that are equivalent because you can't really change the line, but you can do stuff to an equation to make it a lot easier. And that's the best part about this section. It is a fantastic section. We can just change numbers to suit our needs. Not always, but if it's available to us, I'm always doing it. So for instance, I want to create equivalent equations for the following. You can do whatever you want to create an equivalent equation. For instance, I can multiply everything by 2. I want to get rid of fractions. I don't want fractions in my linear equation. No problem. 2y equals x minus 3. Done. This is an equivalent linear relation. I just multiplied everything by 2. This next one, I'm just picking random numbers here. Yep.
It's negative 6.
You the man. Okay, this next one, I'm going to pick a random number. I feel like multiplying everything by 3. No particular reason. So by multiplying everything by 3, I'm going to create an equivalent relation. 9x, 12y, 6. Done. There's going to be questions, you're going to see decimals, especially in this chapter. There's going to be questions where you're going to see fractions in this chapter. You can come up with an equivalent linear relation that doesn't have either of those if you truly want, and then you don't have to deal with them. So for instance, if I have decimals here, I'm going to multiply this one by 100. This is going to guarantee all the decimals are going to be gone. So by multiplying by 100 here, this is just going to be an x, this is going to be a 300y, and this is going to be a 40. So I just multiplied everything by 100. And this might be easier to use than this. It might not, but it more than likely is. Okay, once we start doing all these equivalent relations, most of the time we like to multiply in math to get different things. Never stop thinking about dividing first. So an equivalent linear relation doesn't have to be times by 2, 20, 30, and 10. I can actually divide and make the number smaller because I'd rather work with smaller numbers than bigger numbers. So if this is one of my equations, I can just divide everything by 5 or multiply it by 1 over 5, however you want to think of it, and I can get an equivalent linear relation. Okay, and these are much smaller numbers. Okay, so when we get to 1.4, not so much in substitution, you don't really have to do this, but in 1.4, you're going to have to make equivalent linear relations, and you don't know why yet, but you'll see. And that's how easy 1.3 is.